Hey guys, it's Gator, and we're doing some Pokemon battling today. If you hate math, leave the video. We're about to tackle an AP Calculus AB free response question that I did approximately, no, exactly 9 days ago. And I don't remember how to do half the calculus things I learned, which is really bad. I looked at some of the free response questions again. I was like, oh, what do I do? I don't remember. So I decided to do one that's not calculator. So I just scroll down to the last one because I know that one's not calculator. So we're just gonna do it and see what happens. We don't have the answers, so we don't even know if we're gonna be right. That doesn't fucking matter, cause I know I'm right. Okay, don't be like that. That's how dicks act like, and douchebags, and snotty nosed little wieners. I'm not gay. I'm sorry. I said dicks and wieners. That's pretty stupid of me to do that too. Make sure this brush is nice. That's a nice looking brush. We got Santa, we got LOL, and cat. I don't know what any of that stuff is. This would have been like my sister or brother. So it says for times between 0 and 12, a particle moves along the x-axis. The velocity of the particle at time t is given by this equation, cosine pi over 6t. The particle is at position x equals -2 at time equals 0. They try to confuse you with the x coordinate, with the x equals -2. That's really a y coordinate. So let me see if I can show you my bad drawing. That looks like a face. That's a point. That is a point where it is. So it says for 0 is greater than blah blah blah. 1 is a particle moving to the left. I don't like this brush. The particle moves to that brush looks bad too. Pencil. Particle moves to the left when the first derivative is negative. So we take the derivative. Oh no, we don't. They give you velocity. This isn't a displacement function. They give you the velocity, so they don't want you to try too hard. They just want you to set this equal to 0 and make a sign chart and see where it's negative from 0 to 12. So we're going to do that. We can try to do that in our heads by using the unit circle. Cosine is equal to 0 at where's cosine equal to 0? It's pi over 2 and 3 pi over 2, I believe, because at 0 it's 1. Yeah, I think pi over 2 and 3 pi over 2 is the correct answers for that. But we need this. We need it to fit in here. So what gives us pi over 2 in here? Well, that's t equals what the shit? Whatever, t equals 1, 2, 3. 3. We put 3 pi over 6, same thing as pi over 2, and 9. 9 pi over 6 is 3 pi over 2. So we have our t values over here. So now we have to make a sign chart. Well, this is the easiest way for me, at least, to determine. On the AP test, they want you to label this, so you have to put like v of t. And we put 3, we put 9. And at these points, the particle is not moving. 0, not moving. And here we just put negatives or positives. Negative means going to the left, positive means going to the right. So let's plug in 0. Cosine of pi over 6 is a positive number, so it is moving to the right for this whole area. Horrible plus signs. Cosine of pi is negative. So I'm pretty sure. Okay, I'm sorry. If we plug in a 6, which is in here, we're gonna get pi, and cosine of pi is negative. And if we plug in a number bigger than 9, let's plug in 12. That gives us cosine, because it is from 0 to 12, including 12. That gives us cosine of 2 pi, which is 0. So don't check the endpoints. Don't check the end. Fuck the endpoints. 11 pi over 6 is positive for cosine. Anything on the right side of the unit circle is positive for cosine, up until pi over 2 and 3 pi over 2, which is these things. So when's the particle moving to the left? Is there like a text box? Can I put a fucking text box? I don't want to type it. I don't want to draw it. Here we go. So for part A, let me move my text box. A, the particle is moving to the left from time t equals 3 to time t equals 9. I think I did that right. If I did it wrong, my buddy Chimpact will let me know. He's an expert. Oh shit. Control Z that. Okay, just give me my fucking brush. Why does this shit disappear on me? Oh my god. My brush. My pencil. Okay, part B. Look at my background. Gay as hell. This is my desktop. Not mine. Family desktop. Okay. Right? But do not evaluate. That's why it's a non-calculator. So this was A. This is going to be B. Write but do not evaluate an integral expression that gives the total distance traveled by the particle from time equals 0 to time equals 6. That's the integral of this from 0 to 6. The total distance traveled. Yeah. So see, from 0 to 6 of... Do not evaluate this. I think that sounds too easy. T D T total distance traveled, absolute value. You need the absolute value. Horrible absolute value lines. Horrible, but that is what you need. So that looks to be correct. What absolute value does makes all those negative values positive, so when you add them all up, you will get the total distance traveled and not just the displacement, which I'm pretty sure most of you don't know what displacement. I'm kidding. I'm going to assume my audience is decently educated, besides the cheese. It's not decently educated. Part C. Find the acceleration of the particle at time t. Thanks. Is the speed of the particle increasing, decreasing, or neither at time t equals t equals 4? Explain your reasoning. The acceleration is the derivative of this, and it's asking at 4. So first let's take the derivative. So acceleration in respect to time equals the derivative of cosine. The derivative is negative sine. Negative. Oh, but there's chain rule, so it's going to be negative sine pi over 6t times pi over 6. So this I'm trying to think. Yeah. Is that right? Acceleration negative cosine. Negative cosine pi over 6t times pi over 6. And we just put pi over... We move the pi over 6 in the front and negatives in the front, and everything's nice and neat. Now we, A of 4 equals negative... This is going to get messy, I think. Oh, no, it's just asking... Is find the acceleration of the particle at... Oh, I have to find... I actually have to do it. Do I? Find the acceleration of the particle at time. No, it says at time t, so just... This is the acceleration of the particle at time t. Is the speed of the particle increasing... We just need to find this negative or positive. Plug in 4 and you get 2 pi over 3. Sine of 2 pi over 3 is a positive value, and that's going to be multiplied by a negative number. So A of 4 is negative. A of 4 is less than 0. As the speed of the particle, velocity, which is velocity, well, it's not really, but Is the speed of the particle increasing, decreasing, or neither? So we need to also know the velocity at 4. We don't need to know the numbers, and it's also negative. Now this is where they try to trick you. It asks if it's the speed is increasing, decreasing, or neither. But you have to think conceptually that there's a little dot moving on this, like a line, like this line right here. The negative simply means it's going to the left. So its velocity is going to the left, and acceleration is also going to the left, which means it's speeding up in the left direction. Like, I don't think I explained that good enough. There's really no other way to explain I can think of. If acceleration was greater than 0, then it would be slowing down in the left direction. Like it would still be going left, but it would be slowing. It would be getting slower and slower and slower while it's going that way. It wouldn't be speeding up over there. So it's definitely the speed of the particle. That's why at speed, if it has velocity, velocity is decreasing, but the speed is the absolute value of velocity, and therefore it is increasing. So we state that the speed of the particle at time t equals 4 is increasing because v of 4 and a of 4 are both contain negative values. Let's go with that. And you assume that the person grading it knows what I'm talking about, so. Because, yeah. Both contain negative values. That sounds right. And part D, I don't even know where the fuck am I going to put part D. We're putting part D over here. Make a line. D. Find the position of the particle at time t equals 4. That means I actually have to integrate that without the absolute value. At time t equals 4. Find the position of the particle at time t equals 4. Oh! They gave us this point at the beginning. And so at time t equals 0, the particle is at position -2. So our formula for solving this is going to be -2, because that's where it starts, plus the integral from 0 to 4, because it's asking about time t equals 4, and we know where it is at time t equals 0. I'll try to explain after I write it. Of v of t, which is this thingy over here. I don't feel like writing it. You always have to put d. You always have to say what it's in respect to. This will give us the particle's position at time t equals 4. Basically, it's like here's where it starts. If you find how much it changed or whatever direction it went, then you can automatically tell where it ends. If that makes any freaking sense. Let's say you're driving on the highway and you started from the gas station and you drove 50 miles in said direction, and that's it. You did not take any turns or anything. You can tell exactly where you are just by going 50 miles in that direction. You know where you are, or anyone can know where you are if they knew that. If they knew you started here and you went 50 miles that direction. It's like giving directions. Like start here, then go this way, and blah blah blah, and you'll end up wherever. And this time we're finding out where we're going to end up, because we don't know where we're going to end up, apparently. We just know it's at time t equals 4. So now we're going to do it. -2, we'll worry about that later. We need to integrate this. Integrate that, we need to do something called substitution. There's a problem. That's nasty. That's not going to look good. I don't think I want to do that. It's going to be a lot of work. This is what you have to do, but if I have to do it like on pen and paper. Okay, cosine of u. We say u's and the derivative of, fuck it, fine, I'll show you. It's basically like making up your own variables. So we're going to say u, you'll see what I'm talking about in a minute, equals pi over 6t. If you don't want to watch this, then don't, because this might take a while. I'm not sure. And du, which is the derivative of u, is just pi over 6. But we don't have pi over 6 anywhere in this equation if we replace this pi over 6t with u. We're just going to have cosine of u. And we need it in respect to u. Like up here you have it in respect to time. We need it in respect to u. So the only way we can do that, I'm sorry, dt, and then this. Because this is supposed to say our integral expression up here is dt. And we need to like plug things in. And there's no pi over 6 in our integral expression thingy majigger dt. Like take this, because I didn't write that. Take this and just shove it into vt. So it's the integral from 0 to 4 of cosine pi over 6t dt. And if we plugged in u into this, we have the integral from 0 to 4 of cosine of u dt. And that's it. Because we don't have this thing anywhere to plug it in. So we have to make this only dt, if that makes any sense. So we have to multiply both sides by 6 over pi. So now we have that 6 over pi du equals dt. So now we can put this into here. But what you want to do is you want to take the constant and you move it outside of the integral. That's just how things go. So this is what our integral thing looks like now. Cosine of u du, see now it's in respect to u because we plug this in here and this 6 pi gets moved out to the outside. Yeah, no, I'm not making any sense, I'm sorry. If I am, thank you. But if you notice here it says from 0 to 4, but since we're using a different variable, our limits to integrate this have changed. So what we do is we take the 0 and 4, which are in respect to t, like they go with t, and we plug them into this equation, which changes our t values into u values. So now it's from pi over 6, no, it's from 0 still, because 0 times pi over 6 is 0, and 4 times pi over 6 is 2 pi over 3. So that's our expression right now. So now we have to integrate, and the integral of cosine is just sine, so that's easy. So we have sine of u, and you have to do the 6 pi. Don't forget about the 6 pi, like this is still here. And we evaluate it from 0 to 2 pi over 3. I'm going to do most of this in my head, or at least try to. So it's 6 pi, and for the 6 pi you have to multiply both of these thingies by, I'm trying to show you what I'm talking about. That's a 3. And then minus 6 pi times sine 0. Sine 0. Yeah, whatever. I'm going to try to do some of that in my head. Sine of 2 pi over 3 is radical 3 over 2. So, wait, is it 2 pi over 3? Yeah. Radical 3 over 2, and we can just do, it would be 6 pi times radical 3 over 2. The 2 cancels 1 and 3, so on this part we have 3 radical 3 over pi. That's this, I think. So I know I'm screwing something up. I'm sorry. Minus sine of 0 is a 0. So that's easy, that just says 0. So that minus that is just this. But don't forget this. So see, now this is how much it went. This is like the miles it went. So we have to do negative 2 plus this, which is a disgusting thing to look at. I don't even know if that's right. Sine of 2 pi over 3. 1/3, 2/3. It's the highest. It's the radical 3 over 2 is right. And multiply that by 6 pi. You get 6 radical 3 over 2 pi. And you can make it, yeah, that's right. Okay, so now we have to make this over pi. So, common denominator stuff. So, negative, Jesus Christ. What do I do? I can't even see anything. Right? Does that look right? That, man, I'm trying too hard now. Now I don't even remember if I can do this. Is this legitimate? Can you do that? Are you allowed to do that? Yeah, you can. You just cross it out as -2. And then, so our final answer, apparently, is -6. No, what am I doing? Sorry. -2 plus 3 radical 3 over pi. Now, don't ask me if this is right. I did the process right, I think. And like I said, I forgot most of my calculus, so this was a good refresher in case, you know. But a really neat tip or neat trick in the AP, you don't have to simplify anything. So I could have just left it like this, and they would have to do the work themselves. I could have left it like this answer. They'd have to do the work themselves, but I can't do that. I have a knack for just fixing shit. There you go. We answered a freaking free response question. I had to do 6 of these bad boys. Yo, fuck that problem. That problem was a bitch. It was like fuck it. Look at these things, man. Look at these. That looks so easy, right? It's not. Anyways, there's some math. Try to show off my smarts. I don't know how well that went. I'm also in AP Statistics, and I took that FRQ 2 days ago. Not FRQ, AP test 2 days ago. So anyways, yeah. So there's number 6. I'm gonna stop the video now if I know how to stop it. How do I stop it? Where's the cam? Oh, there it is. No, it's my speaker. Oh my god. Oh, there it is. Look, it says stop right here. Yeah, itzGator. I'll see you guys next time.